All right, welcome back. We're going to talk about Amazon Transcribe. Before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So, converting voice into actionable text. Voice communication drives business interactions worldwide, from customer service calls to conference meetings, medical consultations to podcast interviews. Amazon Transcribe transforms the spoken content into searchable, analyzable text using advanced automatic speech recognition technology. Beyond simple transactions and transcriptions, it provides intelligent features for privacy protection, multilingual processing, and content moderation that make it essential for modern AI-driven applications. The technology behind it. Amazon Transcribe employs automatic speech recognition, ASR, which is powered by deep learning models that have been trained on diverse audio datasets. Unlike simple voice-to-text conversion, this system analyzes speech patterns, tone variations, word boundaries, and contextual clues to deliver accurate transcriptions even in challenging acoustic environments. The service processes audio by examining multiple layers of information, acoustic features like pitch and cadence, linguistic patterns, including grammar and vocabulary, and contextual relationships between words and phrases. This multidimensional approach enables it to handle accents, background noise, multiple speakers, and domain-specific terminology with remarkable accuracy. Amazon Transcribe integrates seamlessly within the broader AWS ecosystem. Audio files typically flow from S3 storage into Transcribe for processing, then connect with Amazon Translate for multilingual support, Amazon Comprehend for sentiment and entity analysis, and then Amazon Kinesis for real-time streaming, and Amazon Lambda for automated workflow orchestration. This integration capability transforms simple transcription into comprehensive voice analytics pipelines. Okay, so real-world applications. So the practical applications of Amazon Transcribe span industries and use cases where voice content needs to become actionable intelligence. Customer service organizations transcribe support calls for quality analysis, compliance monitoring, and training purposes. Media companies create searchable archives from podcast content, interview recordings, and video libraries. Healthcare providers document patient consultations while maintaining HIPAA compliance through automatic PII redaction. And legal firms transcribe depositions and court proceedings for case preparation and analysis. The service excels in scenarios requiring real-time processing like live customer support, conference call captioning, or broadcast subtitling. It also handles batch processing efficiently for large audio archives, recorded meetings, or content libraries requiring retrospective analysis. Okay, let's get into the console and take a look. Okay, and Amazon Transcribe. Let's go over here. So the most effective way to do this is through a little bit of experimentation. So let's go over here, select real-time transcription. We'll choose English. So we have a specific language, automatic language identification. And here's the languages that are listed, multiple different types of English, Farsi, Finnish, French. Okay. And then you can up here and click start streaming, right? Oh, automatic language. How about this? Okay, let's go start streaming. Okay. Hello. We're using Amazon Transcribe. It's the most effective way to understand Transcribe's capabilities and how to use this within the AWS console for using your business intelligence needs. Okay. Let's try this one more time. Start a new stream. Okay. Hello. We're using Amazon Transcribe. This is the most effective tool for transcribing audio into text. With this, you can use it to handle large audio archives, recorded meetings, or content libraries for retrospective analysis. And you can use this for any other business intelligence needs you have. Stop streaming. Okay. So the system will display transcribed text instantly, and it demonstrates the low latency processing that makes real-time applications possible. This immediate feedback loop helps you understand how Transcribe handles different speaking patterns, accents, and acoustic conditions. My voice isn't that far off from being, heavily accented, but gives you an idea. Then there's also different features you can have in here. All right. Okay, speaker partitioning. So you can get variability between the languages. You also have vocabulary filtering. So you can filter out certain, let's say, swear words, something along those lines. Customizations, like custom vocabulary to recognize. Oops. Results that don't change the process of transcription. Partial results. Okay, so that looks like it gets the output as stable as possible. So you can use larger or smaller models to make sure everything's more stable, and custom language models. So if you want to use, more customized language, basically to make sure that if you have someone speaking a colloquial or a dialect, it would get closer and closer. So the privacy features. So let's see. Maybe in batch. How am I seeing this? Post call analytics, real time transcription. Let's see, application. No, that's for the application. Let's see, custom language, custom vocabulary filtering. Let's leave the page. Okay, so you can have a vocabulary filter here. Create, let's say, instead of just letting me create this. All right, let's see, custom vocabulary. Let me, okay, there we go. So that's working. Let's try this. There we go. Okay. So you can have a vocabulary filter. You can use a regular file. You can have an S3 upload, and you can tag it as well. Real-time transcription. You can do this, which we just did. Transcription jobs. You can set up jobs to run automated. Okay. So there's also different privacy features, which I'm not. Category management. Post call. No. Let's see. Why am I not seeing it? Custom vocabulary. Adding phrases to the form. No. Create vocabulary filter. That's probably going to be one way to do it, but I am not seeing it. Okay, so the medical insights will help you. It's definitely with this. So you can use this to get more medical jargon, use some masking. That's what I'm looking for, but I'm not seeing it here. So I'm thinking the custom vocabulary. I'm likely just not seeing it. So, but we'll move on. But basically, there's privacy features so that you can redact certain PII, right? And you can mask it if necessary. And the multilingual processing capabilities also are enabled. If you go back to the real time where we showed you here, you can select from multiple languages that are available. So the multilingual capability lets you enable global customer support. You can use this for international conference transcription and content localization workflows, right? So you could upload an MP3 or a WAV file to an S3 bucket, and then go to transcription jobs. From here, you create the job, your transcription job, specific language or automatic language identification, or multiple languages, select the languages, and use that S3. Okay. And then you have advanced features, like identifying speakers, customer vocabulary, and some PII redaction if necessary. And you see the encryption here as well. Okay. But the batch processing can be used here for multiple files, and it can handle high volume scenarios. It's ideal for processing something like a call center archive or meeting recordings. Okay. Okay. So advanced customization. Let's see. Yeah. Okay, so advanced customizations we just talked about, but basically real-world audio often contains terminology that standard speech recognition models struggled with. Think brand names, technical jargon, acronyms, or industry-specific language. So Transcribe provides two powerful customization tools to address these challenges, which you just showed you. The custom vocabulary, all right? So this addresses the real-world recognition issues by teaching Transcribe how to recognize and spell specific terms. When the system might transcribe AWS microservices as AWS or USA microservices. You think about that. A custom vocabulary will provide the correct spelling and pronunciation guidance. And then you have custom language models, right? So a CLM or custom language model goes beyond individual words to understand contextual usage and phrasing patterns. By training on domain-specific text, CLMs help Transcribe understand that in an IT context, something like microservices is one concept, while in a restaurant setting, microservices like MYCROWSERVICE, microservices. Okay, might actually make some sense. The combination of both approaches delivers optimal accuracy for specialized domains. Think healthcare technology, legal language, technical support, or any industry with specific jargon. Okay, let's go over to here. Okay, so content safety. So modern applications really need to identify and respond to problematic content automatically. Transcribe's toxicity detection feature analyzes both audio characteristics and transcript content to identify potentially harmful speech. The system examines speech cues like tone, pitch, and emotional intensity alongside text-based indicators such as profanity, threats, or harassment languages. All right? It categorizes detected toxicity into specific types: profanity, sexual harassment, hate speech, threats, insults, and graphic content. This dual analysis approach, combining acoustic and linguistic signals, provides more accurate detection than text-only systems. So it enables applications in content moderation, customer service quality monitoring, and social media safety. Okay, so economic considerations and monitoring. All right, so Transcribe operates on a straightforward usage-based pricing model at about 0.4 of a cent per second for both batch and real-time transcription. Custom vocabularies are included at no additional cost, while custom language models and toxicity detection carry additional fees based on usage volume. Monitoring. All right. So the service integrates with CloudWatch for comprehensive monitoring, tracking successful versus failed transcriptions, job completion rates, error patterns, and processing throughput. This monitoring capability enables automated alerts for transcription failures and provides operational visibility into usage patterns and system performance. Voice-enabled AI architectures. Okay, so Transcribe serves as a foundational component in voice-driven AI workflows. Common architectural patterns include speech processing pipelines that flow from audio input through Transcribe for text conversion, then to comprehend for sentiment analysis, followed by translation services for multilingual support, and finally to data storage or real-time response systems. Contact center intelligence workflows leverage Transcribe to convert customer calls to text, apply PII redaction for compliance, perform sentiment analysis to identify escalation opportunities, and create searchable archives for quality assurance and training purposes. Media and content workflows use Transcribe to create searchable metadata from video and audio libraries. They enable automatic subtitle generation, support content discovery through full text search, and facilitate content localization through integration with translation services. The service transforms voice from an ephemeral communication medium into persistent, analyzable, and actionable business intelligence, enabling organizations to extract value from audio content that was previously difficult to process at scale. And that's what we have for Amazon Transcribe. Before we get out of here, hit the like button, subscribe, share this with anyone you know who's taking the AWS Machine Learning Associate exam. And the next time we'll get back to you, we'll be on Amazon Poly. But until then, have a good day.